February 8, 1942. A humid morning on the island of Java. The war in the Pacific had turned swiftly and brutally against the Allies. At Yogyakarta airfield, a massive American bomber lay silent under the tropical sun. The Boeing B-17E Flying Fortress, serial number 412471, sat abandoned, its olive-green skin streaked with oil and dust. Its American crew had fled only hours earlier, retreating before the relentless advance of Japanese forces. The aircraft was battered, its engines stripped, the nose section shattered, but the heart of the machine remained intact. Within days, Japanese troops would arrive, and among the spoils of war, this wrecked B-17 would become one of their most valuable discoveries. What began as curiosity would soon turn into revelation, one that would shake Japan's confidence in its own industrial power. When Japanese forces completed their conquest of the Dutch East Indies in March 1942, teams of engineers and aviation experts began combing through captured Allied airfields. At Majoran Field in Java, they found B-17E 412471 still largely intact. Across the island, at Malang, Cirebon and Bandung, other flying fortresses awaited in varying states of damage. Toro Siaito, an aviation journalist from Asahi Press, toured these captured bases soon after occupation. He wrote later that the American maintenance facilities in Java were astonishingly advanced for such remote locations, clean, organized and efficient. At Bandung Field, the Japanese discovered what appeared to be a major service hub for American heavy bombers. There, a specialized team from Tokyo's Air Technical Research Institute, the Koku Gijutsu Kenkyujo, or GIKEN, began their meticulous study. These were Japan's best aviation engineers, men who had designed aircraft like the Ki-43 and Ki-61. When they heard several B-17s had been captured intact, excitement spread through the halls of the institute. Teams were dispatched immediately to Java. Restoring the captured bombers to flying condition was an immense challenge. The B-17E represented the cutting edge of American aeronautical engineering, advanced hydraulics, electrical systems, and supercharged radial engines, all alien to Japanese design philosophy. For months, Japanese engineers worked alongside captured Allied mechanics, painstakingly piecing together two of the bombers, using parts scavenged from others. They studied manuals, translated diagrams, and learned American technical terminology, line by line. By late 1942, after endless nights of labor, two B-17s were airworthy again. Both aircraft would be flown to Japan for full evaluation, a dangerous journey across thousands of miles of recently conquered territory. To prevent friendly fire, detailed flight plans were issued to every air defense unit along the route. Fighter escorts and a Nakajima L-2D transport aircraft, Japan's own copy of the American DC-3, accompanied them. By mid-1943, the two flying fortresses reached Tachikawa Airfield safely. They joined another B-17D captured earlier in the Philippines. Now Japan's engineers had three examples of America's most formidable bomber sitting on their own soil. Major Kazuyuki Saito of the Imperial Japanese Army Air Force led the evaluation. A skilled aeronautical engineer, he assembled an expert team, test pilots, structural analysts, and engine specialists. Their mission: to dissect, study, and understand every bolt, wire, and panel of the B-17. What they found left them stunned. The airframes were nearly identical down to the smallest detail: rivet spacing, panel shapes, structural members, all perfectly uniform. In Japanese factories, aircraft were hand-built by skilled craftsmen, each adjusted and filed until the parts fit. No two planes were identical, but these American bombers were different, almost machine-like in their precision. Every part fit perfectly without adjustment. When they examined the engines, the Wright R-1820 Cyclones, their astonishment deepened. Hundreds of components, all machined to microscopic tolerances: cylinder heads, pistons, crankshafts, every part interchangeable between engines. American. Mechanics could swap major components in the field with little more than wrenches. To the Japanese engineers, it was a revelation. Precision did not come from the hands of craftsmen, it came from the machinery itself. The hydraulic and electrical systems told the same story: standardized fittings, modular connections and machine-crimped. Wiring replaced the hand-soldered joints common in Japanese designs. Even oxygen regulators were stamped with logos from American automobile companies, showing that ordinary car part manufacturers could produce aircraft-grade components on demand. It became clear that the United States didn't just build planes, it built systems that could produce planes faster, cheaper and more consistently than any nation on Earth. By autumn 1943, all three captured B-17s were flying regularly at Fusa Airfield near Tachikawa. Japanese pilots took them up, recording handling characteristics and flight data. The bombers even appeared in training films and propaganda reels, shown being intercepted by Japanese fighters. But in private, pilots admitted the truth. The B-17's defensive firepower and resilience were terrifying. 13 50-caliber Browning machine guns covered nearly every angle of approach. Attacking a formation of these bombers, they said, was like flying into a wall of lead. Even more alarming was the industrial arithmetic behind it. For every bomber shot down, American factories could produce 2 more before the next sunrise. In early 1943, Asahi Press published Anatomy of the Enemy's Aircraft, a detailed technical manual featuring the captured B-17s. Engineers and designers across Japan studied it religiously. Mitsubishi's Hisajo Ozawa and Kawanishi's Shizu Kikuhara wrote analyses praising the bomber's sophistication and integration. But beneath the admiration lay quiet dread. Japan could not build such machines in similar numbers. By cutting open the damaged B-17 wings, engineers measured the rivets. Their diameter and depth varied by less than 1/10,000th of an inch. Such precision could only come from automated machinery. Japan, by contrast, still relied on hand riveting. The implications were devastating. If America could build such complex machines with this level of consistency, its production could scale indefinitely. The bottleneck was no longer skilled labor. It was only how fast factories could feed raw materials into machines. In 1944, one of the captured B-17s was destroyed in a taxi accident, giving engineers a final chance to cut it open for detailed study. What they learned confirmed their worst fears. The United States had mastered industrial warfare. By 1944, America was producing nearly 100,000 aircraft a year. Japan barely reached 28,000, and most of them required extensive hand-fitting and repair. For every Japanese plane in the sky, 5 American ones waited on the runway. By war's end, Boeing alone had built nearly 7,000 B-17s. Douglas and Lockheed added another 5,000 combined. In some months, American factories rolled out 16 flying fortresses every single day. The Japanese engineers at Tachikawa didn't know those numbers, but they could feel them in every rivet, every joint, every perfectly fitting part they examined. The B-17 wasn't just a bomber. It was a physical manifestation of an industrial civilization operating at full efficiency. After the war, when Japan lay in ruins, many of those same engineers who had studied the captured bombers helped rebuild their nation. They carried with them the lessons of the B-17, that precision must come from process, not from hands, that quality was born not from craftsmanship, but from systems. Factories that once relied on artisans were restructured around automation. Tooling replaced intuition. By the 1960s, Japan was producing cars, cameras, and electronics with the same level of precision that had once astonished its wartime engineers. By the 1970s, Japanese manufacturing had evolved even further, introducing just-in-time production systems that would eventually inspire American factories to learn from them. The circle had closed. The captured B-17s had taught Japan that it had lost not because its pilots lacked courage or its aircraft lacked ingenuity, but because its factories lacked systematization. The lessons learned in the hangars of Tachikawa became the blueprint for Japan's industrial miracle. The flying fortress, a machine built for war, had become a silent teacher of peace and progress. And in a final irony, decades later, American engineers would travel to Japan to study their manufacturing methods, lean production, efficiency, and precision, all born from lessons first learned in 1943 from a handful of captured bombers. The Boeing B-17 dropped over 640,000 tons of bombs during the war, but its most lasting impact was not destruction, it was education. It showed the world that victory in modern war and success in modern industry depended not on the brilliance of craftsmen, but on the brilliance of systems. From the muddy airfields of Java to the factories of post-war Tokyo, the Flying Fortress carried one final mission: to teach its enemies the secret of American power, and in doing so, to help them build a future where industry, precision, and peace could take flight together.